Math 3, Unit 2, Section 1. Today we're talking about analyzing piecewise defined functions. This concept is building on what we did last unit. Okay? So there are a few things or definitions we need to understand. So the first one is that a function is increasing on an interval when its y value increases from left to right. And we're going to come back to this later, but I want us just to look at this graph. Whenever you're reading a graph, you're like reading a book. And you read a book starting at the left side going to the right, correct? So graphs are the same way. So if you're starting from the left, do you see right here how this is increasing? It's going up when you start left, and then all of a sudden it goes down here. And then here it's going up. Okay, and so increasing is when it's going up. Decreasing is when it's decreasing, when it's going down from left to right. So do you see right here, this is where it's going down. So that's decreasing. Okay, a function is constant on an interval when its y value remains the same. Do you see anything on here where the y value is remaining the same? No. It's either increasing, decreasing, increasing, and then it's stopping. Okay, so there's no constant on this graph. Okay, a relative minimum is a point where the function changes from decreasing, wait a second, yeah, from decreasing to increasing. And this is important to remember because it has to be changing from one direction to the other. Okay, so see there's an endpoint right here. This is not a relative minimum or maximum because it's not changing from increasing to decreasing. It's stopping. Okay, do you see at this point right here how this is changing from increasing to decreasing? Okay, this actually, because it's changing from increasing to decreasing, this is a relative maximum. So we're going to write that here. So this is changing from increasing to decreasing. This point right here is a relative minimum because you can see here how it's decreasing and then it changes to increasing. So it has to be changing directions in order for it to be a relative min or a relative max. Okay, so now we're going to answer the following questions, which we kind of already have done when we were talking about the graphs. But it says, state the open intervals on which f is increasing. Okay, I'm also going to highlight one line on here. And it's just going to be right here because you can see the graph changes there. So right here, what type of function is this? Parabola. A parabola or quadratic, good. And then on the right side, this is it's linear or a line, good. Okay, so when it says open interval, open means you're going to use just your parentheses. Okay, so open means because when you have a bracket, it's when it equals and it's stopping at that value. An open interval just means they just want to know the interval. You're only using parentheses. So when you see that word open, you don't have to worry about parentheses or brackets. You know you're just going to use parentheses. Okay, so where is the graph increasing? So if we start from left to right, where is it increasing? How would we write that? So here, and again, if you're kind of like looking at this, right? This, it's starting at negative infinity, right? Because it's going down there. So that's negative infinity. And then it increases all the way until you get to this point. Because at this point, this is when it's changing directions, right? And so what's that value? Okay, and if you can't tell, and maybe you might want to like draw this darker, but this right here is my y-axis, and I can't draw a straight line. This is my x-axis, and so maybe you can see that better now that it's darker. Maybe I should draw like arrows here too. Okay, so what is that point? The x. So whenever we're doing like our intervals, it's on the domain. So you're only looking at the x values, okay? Very good. So -1. And is there another interval where the graph is increasing? Where does it start at? 1 and goes to what? Yeah, we can do a U. That's good. 1 and it goes to what? 7. Because remember, this is our 0, 0. So 1, 2, 3, 4, 5, 6, 7. Okay. State the open intervals on which f is decreasing. So looking at the graph, where is it decreasing? -1, so it's decreasing right here. It starts at -1 where it's decreasing, and it decreases until it gets to 1. Any questions so far? Okay, so now it's saying state the domain and range. It's not saying open intervals, it's saying domain and range. We have to think about our parentheses and brackets, okay? So starting with our domain, what is, and again, you should, if you have a hard time with this, you use like your cards, but starting with the domain, we're starting with what? Good, -infinity. And is it going to be a parenthesis or a bracket? Good, parenthesis, -infinity. And then as we go along, it keeps going, and then it stops because there's a point there. Okay, and so what point is that at? 7. And would I use a parenthesis or a bracket? Very good. And why is it a bracket? Good, closed circle. It equals that point. Okay, range. So range is our y values going up and down. If you've forgotten this, you might want to put an x by domain and a y by range. So with my range, we're going up and down now. It's starting at what? Very good, -infinity. And so we use a parenthesis because we always use those on infinity because they don't stop. And it goes up, 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 up. And then it looks like this is my stopping point right here. So where is that? What was it? 4, good. And is that a parenthesis or a bracket? Very good. Okay, any questions about any of that, even if we've already talked about it before? Any questions on parentheses and brackets? Any questions on infinity? We're good? Okay. So something new, though, is our relative minimums. So is there a relative minimum here? Is there a point where the graph is changing from decreasing and then it goes to increasing? Good. And what point is that at? So if we go right here, remember this is our coordinate, this is our 0, 0, and so this minimum right here, that is at 1, 2. So coordinates, we have to state our ordered pair, and so that's 1, 2. The relative min is at that point. Is there a relative maximum? Okay, good, and that point is right here. And if you want to, maybe you want to write this on your graph. So that's our max, that's a min. It can have multiple relative maxes and mins, okay? And what is that ordered pair? Very good. -1, 4 is correct. Are there any other maxes? Okay, the answer is no. Can anybody, do you remember what I've said? Why is this value not? It's what? It just stops, and in order for something to be a max or a min, what has to happen? Good, it has to change. It has to change directions. This is not changing, it's just stopping. So it has to go from increasing to decreasing or from decreasing to increasing in order for it to work, okay? All right, so this last part is we need to write a 2 piecewise function. So this is also a very nice clue, is because they're telling you it's 2 pieces. So you have 1 piece and 2 piece. So it kind of tells you that you're going to have 1 highlight to split it in half. Make sense? Okay, so when you're writing your piecewise functions, we start by writing f of x equals, and we do our brace, where we're going to end up writing our 2 functions. So let's start with the left side of our graph. Okay, we know that's what type of function? A quadratic. Okay, and so I'm going to write quadratic, knowing that this is the work for my quadratic function. And
Just a reminder
what
to
is the
all
maximum
staff,
value?
The impact meeting is about to begin in the library annex. Those that would like to attend, please report to the library annex now.
I should go. You're right. No, nice try. Okay, so your max is your vertex. So on this quadratic function, what is my vertex? Good, negative 1, 4. And so when I write that in my quadratic function, how will I write it? I'm going to move this up for a minute so you guys can see what I'm doing a little better. So we have that vertex. How do I write it? Good. Y equals m, and then we're going to do a parenthesis. And what do I put in the parenthesis? Good. X plus 1, because it's always the opposite x value. And then what is next? Very good. Don't forget your squared term. And then, good, I heard it, plus 4. Can I just go and count my slope on here? No, we need to what? Plug in a point. What would be a good point on this one to plug in? That minimum value. Is this minimum value right here still part of my quadratic? And we know this is an exact point, so it's usually best to find an exact point. And so that exact point is at what? So the point I'm going to plug in is at 1, 2, and I'm going to label that as x and y. My reasoning for always doing that is so that I don't plug in the wrong numbers into x and y. So we go here, and we have 2 equals m parenthesis, and then I'm going to write 1 plus 1 squared plus 4. Okay, 1 plus 1 is what? 2. And 2 squared is what? 4. So I have 2 equals 4m plus 4. Is everybody okay with me kind of doing some shortcuts there? Okay. So next, what am I going to do? Good. Subtract 4 to both sides. I do that and I get negative 2 equals 4m. And then my last step is to do what? Good. And so what does m equal? Very good. So I'm just going to go, and now that I have this information, I know that's going to go into my slope. And so I'm just going to write my equation over here. So how will I end up writing it? Good. Negative 1/2 x plus 1 squared plus 4. So we just took all this information, including my m value, and then this will be if, and what am I going to write? So, good. You have two options. One option, x is less than or equal to 1. Because we're looking at our highlighted line here, and this graph is at the point that's less than or equal to 1. Another way we can write that one is negative infinity is less than x is less than or equal to 1. Both of these answers are acceptable. Whichever one makes the most sense to you, use that one. Okay. So now we have another function. And so let's go back up here and look at our graph. What type of function is to the right? Good, linear. So with our linear function, we can use any point that we want to, okay, to start with. And I'm going to go ahead and just start with this point again, right here. Is everybody okay with that? And so that point we know is at 1, 2. Do we all agree? And do you guys know how to write that into our function? How will I write it? Y equals m, and then we're going to do a parenthesis, and it will be x what? x minus 1 plus 2. Now, when I have a linear function, a line, can I just count my slope? Yes, so that's kind of nice. Less work to do. So my slope, I'm going to count from my minimum point right here up to my maximum. And so my rise is going up 2, so that's a positive 2. So m equals a positive 2, and then it's going over 1, 2, 3, 4, 5, 6. Very good. And what does that reduce to? 1/3. Anybody have questions on that part? Okay, I'm going to go ahead and write this equation now. So this is y equals, we're going to plug 1/3 in for m. So I have 1/3 x minus 1 plus 2. Now, normally when you see a line written, it doesn't have the parentheses like that. If you were to write this answer, that's fine. But if it was a multiple choice test, this answer would probably not be there. So what could I do to change this to the form that I would probably see? Yeah, get rid of the parentheses. How can I get rid of the parentheses? Distribute. Okay, so 1/3 times x is what? 1/3 x, and 1/3 times negative 1 is negative 1/3. Because when you're multiplying fractions, remember, I'm just going to kind of do a side note right here. This is 1/3 times negative 1. And with fractions, you know, you multiply tops with tops, bottoms with bottoms. And so 1 times 1 makes the 1. And 3 times 1 makes 3. And then a positive times a negative is a negative. And then I still have plus 2. Now, the issue here now is that you can combine these like terms. There's a lot of ways of thinking about this. I think the easiest way is that you would change 2 to have a denominator of 3. So if I want 2 to have a denominator of 3, right now this 2 has a denominator of what? 1. So 1 times what makes 3? 3. So 2 times 3 is 6. Does 6 over 3 reduce to be 2? Yeah, so I did it correctly. And so now I have 6 minus 1, which is 5. So this simplified to be 5/3. Okay? So when I write this equation, and this is what you would see on a test if it was multiple choice, 1/3 x plus 5/3. Now, on your homework, if you don't want to deal with this, and I understand not wanting to deal with it, and you just want to leave it in this form, that's okay. But when I show you the answers, they're going to be in this form. Okay? Yes. Wait, no. Because this 2 was positive, so when you have a positive and a negative, you subtract, but you take the sign of the bigger number. And 6 is bigger. When you're multiplying, a positive and a negative always make a negative. Is that good? So this is really just saying 6 minus 1, which is 5, because this is a positive 6. Okay, and then what's going to be my domain over here? It's going from what to what? It's going from 1. So if 1 is less than x is less than or equal to 7. Now, notice here, and this is what we were talking about before, when you have the same number in your piecewise function, one of the inequality signs can have the equal sign and one of them doesn't. Okay? On your test, if you put them on both of them, I'm not going to mark you wrong for Unit 1, but just know that one of them should only have the equal sign. Okay, any questions here before we move on? Nope? Okay. So, we're going to do the same thing again, practicing this again. Okay, now we have a different graph, different functions. Okay, so A says, state the open intervals on which f is increasing. Do we see any infinity signs on this? Will there be any? No, because we have all of these endpoints, okay? And so where is our function increasing? Good. And again, if it's hard for you to see and you want to redraw like the axis here so that it stands out more to you, go ahead and do that. But yes, you were right. It is increasing from 0 to 2. And again, notice how it says open interval. So we're just going to use parentheses. And it's increasing, you said, from 0 to 2, which is correct. Is it increasing anywhere else? No. Good. Okay, now decreasing. Good. Negative 1, 2, 3, 4. So it's going decreasing from negative 4 all the way to 0. Okay, then it's increasing, so we don't write that. And then, is it decreasing again? And so where is that decreasing? What interval? 2 all the way to, good, 4. Okay. Then it says, state the open intervals on which f is constant. Do we see somewhere where it's constant? Yeah, it's constant right here, where it's just a straight line. And so what is that interval? Good. 4 all the way to 6. Yes?
Why is 2, 4 not negative if it's 4 when it's decreasing?
It's still, you're always stating your domain, and so when it's decreasing the domain, it's matching up here at the x value of 2. So right here, it's going from positive 2, it's decreasing all the way to you get to positive 4. So when you're always stating your domain values when you're talking about increasing and decreasing. Good question. Okay, anything else that's confusing right now? All right, state the domain and range. So domain, going from left to right, what is my smallest domain value? Parenthesis or bracket? Good, negative 4, and that goes all the way to what value? So here, negative 4, you went all the way over, and then it stopped there at 6, and will we use a parenthesis or a bracket? Very good. Range. What is my smallest range value? Where is the smallest value on the y? Good. Negative 6 is correct, and we're going to use a bracket because it's equal to. And then as we go up on our y, our highest range value is at 1, also using a bracket. Any questions there? Okay, are there any relative minimum points on this graph? Is there any place where it's changing from decreasing to increasing? Very good. 0, negative 5 is one coordinate where it is a relative min. Do we see any other relative minimum points where it's changing from decreasing and then goes to increasing? No. Very good. Because this one, it's decreasing, but does it change to increasing? No, it changes to constant, and so that is not a relative minimum. Okay, are there any relative maximums? Yes, what's that value? Good, 2, negative 2 is correct. Okay, and here it's changing, it's increasing, changes to decreasing. That is a relative maximum. Okay, so now we're going to write a piecewise function. Notice this one says a 3 piecewise function. So we need to split this into 3. Now, this one was slightly challenging. Okay, and so this part was easy because I can see that this is constant from here to here. And so that one piece is easy. This one, you have one absolute value and one linear. Now, with absolute value, we know that it has to be what? It starts with an S. Symmetrical. If I were to make this one my absolute value, and so I'm like, okay, here is my middle line. Do you see from here to here how that's 2 away, but from here to here it's only 1.5? So that doesn't work as absolute value because it's not symmetrical. But if I look from here to here, do you see how this point right here is 2 away and this one is 2 away? So that is symmetrical. And so this is where my other line needs to be drawn, my highlighted line to separate my graphs. So can you now see here? So here is one function, and then there's 2, and then there's my third. And you could do another highlighted line on this side if you want to, because it's also stopping here. Your ends, though, you don't have to if you don't want to, but it's up to you. Okay, so we're going to write our function. When you are writing your functions, you should have them in order from left to right, going smallest to biggest on your domain. I noticed some people on some of your homework and quizzes, you would like randomly pick different graphs, but you should always start left and go right when you're doing this. So I'm going to start by writing f of x equals making my brace, and then we're going to figure this out. So this first one is what? Very good. Absolute value is correct. Okay, with absolute value, we're going to start with our vertex. Very good. So for this absolute value graph, what is my vertex? Good. 0, -5. What else do we need to write our absolute value graph? Slope. Can I count for slope on this one? Yes. So m will equal, and so if we started our vertex, it's rising up 1, 2, 3, and then it's going over 2. So that is 3 over 2. Also notice how it's going up, which means the slope is positive. Okay, so can we write this function based on this information that I have? Okay, how will I write it? Y equals 3 over 2, absolute value. Okay, so we can either do x plus 0, or what is x plus 0? Just x. You write whichever way makes the most sense to you. If you want to plus 0, that's fine. And then what goes at the end? -5. Any questions there? Okay, so we're going to go right here and write our function. Okay, and so we have 3 over 2, absolute value of x, -5, if, and let's look at our graph, what values is it between? What do we start with? -4 is less than or equal to x, is less than or equal to 2. Okay, are we good? All right, next function. So I'm going to move this over here. My next function here, what is that? Linear. Very good. So we have a linear function. Okay, with our linear functions, I also like to start with a point. And so what would be one point I could start with? Good, 2, -2. Also for my linear functions, can I use my slope? Yes, okay, and so my slope on this one, it is going down 1, 2, 3, 4. So m equals down 4, so that's -4, and then it goes right 2, which reduces to -2, right? -4 over 2 reduces to be -2. Is everybody okay with that? No? Yes. Okay, so how will I write this? Y equals -2x, -2 parenthesis, and then x what? X -2 -2. Okay, because we're using our point and our slope. Now, what do you think I should probably do? Distribute and simplify. So I'm going to distribute there, and I get -2x, and what's -2 times -2? +4. minus 2, and then when I simplify, I end up getting what? Good. Y equals negative 2x plus 2. So we're going to write that in our function over here. We have negative 2x plus 2 if, and let's look back up, and what domain is it here that I would write? Good. 2 is less than x is less than or equal to 4. And again, notice how I have the 2 written twice. One gets the equal sign, one doesn't. You could put the equal sign here and not here. It's up to you. I just normally always put the equal sign on the right side. Okay, last one. We have another what type of function? Linear again. There's no slope or anything on that one. How would I write this function? What is that? Y equals negative 6, correct? So on here, that is negative 6 if, and what is my domain on that function? Perfect. 4 is less than x is less than or equal to 6. And that's it. You have now written your piecewise function. Are there any questions? Okay.